In this video, let's learn how to do a t-test for the mean. The t-statistic is given by deviation of a sample statistic from the null hypothesis divided by estimate standard errors of the sample statistic. In mathematical language, is the x-bar, the mean that comes from the data, minus the mu0, that's from the null hypothesis, divided by the standard error, that is s divided by square root of n. N is the number of observations. Let's solve this exercise. In a sample of 36 job applicants, the average year of experience is 1, with standard deviation equal 3. Test the null hypothesis that mu bigger than 2. Adopt a level of significance alpha equal 5%. First, let's calculate what is the t-value for this alpha 5%. I need a t equal minus 1.68 to get this area here of 5%. This t-value comes from this equation here. Probability of t, a random variable, is smaller a specific outcome, equal 5%. I have to code this equation in the computer to get this t. In Python, you use the library scipy and we import stats. Then we type stats.t, tdistribution.ppf, percentage point function. Then you pass 5%, and 35 is the degree of freedom because you have 36 job applicants. It's n minus 1. See that you get minus 1.68. Now we know if you get the t-statistics inside this critical region, we go and reject the null hypothesis. If the t is not in this critical region, we cannot reject the null hypothesis. Now let's calculate the t-statistics. X bar is 1. 1 year of experience is the average. Mu0 is this 2 from the null hypothesis. And S is the standard deviation equal 3. Divided by the square root of n is 36 job applicants. Then we fill the numbers and we simplify and you get minus 2. Minus 2 is inside the critical region. Therefore, we reject the null hypothesis. Now, let's calculate the p-value. The probability of getting a statistics is smaller than minus 2. Stats.t.cdf cumulative distribution function minus 2 and the 35 is the degree of freedom. We get the 2.66%. Suppose that alpha is 1% rather than 5%. In this situation, we cannot reject the null hypothesis. But suppose alpha equal 3% rather than 5%. In this case, we still reject the null hypothesis. How I know that I have to draw the critical region in the left side and not in the right side? The critical region is given by the null hypothesis. If you see here bigger, equal, then the critical region will be in the left. If this is smaller, then that means the critical region will be in the right side. And you see that it's logical. You collect the data, this x-bar and the standard errors, and get the t-statistics to see if you are going to reject or not reject the null hypothesis.